We're going to look at our second video here on section 8.4, properties of logarithms. Hopefully this goes a little bit quicker than the last one. There's basically three properties that we're going to look at today. And the properties of logarithms are the product property, the quotient property, and then finally the power property. So those are the three properties we're going to look at. And so here is basically the product property. If we had the log base b, so any base, of two numbers multiplied together, m times n, that will be equal to the log base b of m plus the log base b of n. And if you remember when we multiply two common bases together with different exponents or the same exponent, we add the exponents. This is the same thought process here. This is why this works. Now this is true for positive numbers. M is greater than 0, n is greater than 0, and b cannot equal 1. So b is not allowed to, the base can't be 1. That makes sense. Also, we're going to use positive bases as well. So we'll have, m, n, and b all are going to be positive, and the base can't be 1, because if it was base of 1, 1 to any power is just multiplied by 1 times 1 doesn't change anything. Well, you can probably guess what the quotient property would be. If you have the log base b of m divided by n, remember that's a quotient, that would be equal to the log base b of m minus the log base b of n. And finally, the power property, if I have the log base b of m to the x power, that is equal to, take the x out, times the log base b of m. Now, these all relate. If you want to say, what do they relate to in exponential form? These all relate to these following properties that you already knew. Remember that we have said that if you take b to the m times b to the n, that's equal to b to the m plus n. So that relates to there. You can kind of see how that works. If we took b to the m divided by b to the n, that's equal to b to the m minus n. Once again, see how that works. And finally, if I said b to the m to the x, that's equal to b to the m times x. And you can see how we're multiplying now to get that. So you can kind of see how those properties all relate, because these are inverses of the exponential properties. So they should all work very well together. As far as your homework goes, because we're going to give you examples of all these, don't worry. As far as your homework goes, we're going to not do the part that's crossed off here. We're going to do everything down here on the left-hand side. So let's do an example from each of these. So let's do an example of 8. Over here, let's do an example of, we'll do a couple of these. We'll do an example of, that looks like a good one, and this looks like a good one. And we'll do a couple examples of one like this, maybe one like that. And finally, we'll do this one as our final example. So we're going to do 6 examples. Let's get started. Question number 8. We're not supposed to use a calculator. It tells us what the log of 3, log of 4, and log of 5 is, and we're going to use the property of logarithms to evaluate that. So I have the log of 16 over 5. And so you say, okay, that's the same as, based on our rules, the log, and remember, if there's nothing down here, it's a log base 10. Log of 16 minus the log of 5, because that's the quotient property, right? Now, 16 isn't 3, 4, or 5, so I can rewrite this as the log of 4 squared minus the log of 5. Now this 2 I can bring out, so that's 2 times the log of 4 minus the log of 5, which then I can say is 2 times, now log of 4 is 0.6021 minus the log of 5 is 0.6990 according to this. So if I was doing this without a calculator, I would basically end up with 2 times 6.6021 would be 1.2 042 minus 0.6990. And if I take 1.2042 minus 0.6990, subtract, I get a 2, I get a 5, I get a 0, I get a 5, there we go, 0.5052, I believe. So you can see how that can be done. Oops, I rolled out down the bottom there, sorry. You can see how that can be done without a calculator. I could go through and subtract all that. So you got a couple of those to do. You just have to figure out, how can I get these numbers, the 16s, the 5s, the 12s, the 75s, into 3s, 4s, and 5s to apply the property of logarithms. Okay, let's look at another problem. Question number 18. 18 says that I have 1/2 the log of r plus 1/3 the log of s minus 1/4 the log of t. And I am supposed to write that as a single logarithm. So we're going to use our logarithmic properties. So I can rewrite this as the log of r to the 1/2, because the 1/2 can come out here now. Now remember, plus means multiply here, so I'm going to multiply that by s to the 1/3. Remember, the 1/3 is going to come up here, and since it's plus, I'm multiplying. And then this minus means I'm going to divide, so I'm going to divide by t to the 1/4. And so really, I am going to take the log of r to the 1/2. Everything that's written in front of the log multiplied it can be taken as an exponent. 1/3 can be taken as an exponent. 1/4 can be taken as an exponent. Plus means multiply when I put it inside the log, and minus means divide when I put it inside the log. So that's that easy. It's not too difficult as long as you remember your rules or your properties of logarithms. I also said I do 27. So I have the log base 3 of 2x minus 5 log base 3 of y. And so remember, once again, these have to be the same bases, and they are. So we have the log base 3. Now the 2x is going to be in the numerator, and I'm going to divide that by, now this 5 that's out here, remember, comes out as a exponent. And so it's going to be log base 3 of 2x divided by y to the 5th. So there you go. Question 36. 36 asks us to expand the logarithm. So now I have a log of the square root of 2rst divided by 5w. And so if I'm going to expand that, I can simply do something like this. I'm going to rewrite this as the log of 2rst divided by 5w to the 1/2. That's the same as the square root, right? which now if I want to take this 1/2 outside, I certainly can. Remember, this 1/2 applies to every single one of these, so I could say log of 2 to the 1/2, r to the 1/2, s to the 1/2, t to the 1/2, divided by 5 to the 1/2, w to the 1/2 if I wanted to. I really don't want to do that. I'm just going to take the 1/2 on the outside. I could have done that. And so I'm going to say 1/2 times the log of 2rst over 5w. And now I'm going to keep that 1/2 out there, and then it's going to apply to everything, so that way I don't have to do all this 1/2 stuff that I was doing here. And now I've got the log of 2 plus the log of r plus the log of s plus the log of t. So you can see this is getting to be a mess. Minus the log of 5 minus the log of w. And I'm going to keep that 1/2 there. Now you could take that 1/2 and put it in every single one of those. I don't think you need to. If the answer key says that's fine, then I don't really care. But remember, these are all subtracting because they're being divided. These are all added because they're being multiplied. That's as easy as it is. If I look at number 39, I have the log of 2x squared y over 3k cubed. So once again, I'm going to have the log of 2 plus, now this 2 is going to come out in front, 2 times the log of x plus the log of y. That took care of everything on the bottom, or on the top. Everything on the bottom now is going to be minus the log of 3 minus 3 times the log of k. And the reason it's minus the 3, remember this exponent comes out in front. So there you go. One last one to do together, and then we'll be done for the day. 45, it says state the property or properties used to rewrite each expression. So we have 2/3 log of 7 is equal to the log of the cube root of 49. So basically what happened here? All we did was we rewrote this as the log of 2/3. I'm sorry, the log of 7 to the 2/3, because this 2/3 came out here. And then we rewrote it as the log of, well, I knew that 7 to the 2/3, 7 squared is 49, and the index of 3 goes from there. So all we really used there was the power property and then converted. If we would have seen any addition or subtraction in there, then you would have had to use the either the quotient or the product property. Well, I hope this helps you. I know it's brand new stuff. I'll certainly go over it when you get back into class next time. Enjoy your day.